Hi guys, I welcome you all to my channel CSNet Lectures. So in this session, we are going to start up with the algorithmic side of DEQUE. So last class we discussed about DEQUE operations, isn't it? So what is the use of front and rear pointers in DEQUE? So here we are going to discuss regarding algorithmic side. So how we are going to implement algorithms, that is I mean that what are all the conditions that is needed for inserting the elements inside the DEQUE. So what is the plus point of DEQUE? We are using both the front and the rear pointers both for insertion as well as deletion, isn't it? So that's what we have discussed, right? So based on that, we are going to implement certain conditions for inserting, that is the elements using the front and the rear pointer, right? So also we are going to include that input restrictor and output restrictor. So based on that, we are going to write the steps for inserting the elements, right? So basically, if you go for DEQUE operations, we are implementing 4 types, right? Suppose if you are going to use the front pointer, how we are going to insert? Suppose if you are going to use a rear pointer, how to insert? If you use rear, how to delete? If you use front, how to delete? So these are all the 4 basic operations, right? So based on these core points, we will be setting the conditions, right? Then another point, what we are going to say is peak of function. So we are going to use this peak of function to extract the topmost element that is being present in front as well as in rear, right? So this is one of the important points, so please make a note of it, right? So by using the front pointer, I can take the topmost element, and by using the rear pointer, I can also take the topmost element. So that is the advantage of using DEQUE. So we are going to shrink the operations of both the stack and the queue. So by using DEQUE, we are using the operations of both stack data structure and queue data structure, right? Isn't it very interesting? Okay, so now we will see its algorithmic implementation. That is, the main thing what you must have to keep it in mind is what are the conditions needed for inserting or deleting using these 2 pointers. You didn't want to worry about the algorithmic steps. What are all the conditions, how we are going to increment and decrement the pointers, what is the condition for empty, what is the condition for full, all those things we are going to discuss as before for Q1 stack data structure. Right friends, so shall we proceed? Okay, and before starting this, I request you all to please share and subscribe and like our channel, because it will be a great motivation for our team friends, right? So friends, these are the different important conditions for DEQUE while using insertion with front pointer or by using rear pointer. So you must have to be having a clarity about conditions alone. Suppose if conditions is okay with you, so you can easily increment the rear pointer and you can easily increment the front pointer, right? So by seeing this way of representation, I feel that you will be feeling it very easier for remembering, right? So these are all the various possibilities of storage of elements inside the DEQUE data structure. Okay, so what is the expansion of DEQUE? So it is double-ended queue, right? So in this video, we are going to discuss about insertion. Then in the next video, we will discuss about deletion using both the pointers, right? So shall we start? So as a starter, I am going to take first with an easy example. So see, I have represented using 4 ways, right? So first, second, third and fourth. So we are going to go in this order. So first one you see, so it is a very simple one, you can easily answer. So see, this is a DEQUE data structure. So we are using an array representation for storing the elements. So how many number of elements are present? Here we have 5 number of elements. So maximum size of the element of a DEQUE data structure is 5. Okay, we are using 5 elements for storing the data. So what is the maximum size? How it is represented? We are representing it by using n. So by using n variable, we are representing the total number of elements, that is the total size of the array. Next, What are all the other variables we are using is f and r. So all these things you will be knowing. So f is nothing but front pointer and r is the rear pointer. So all these variables are in common. We are using this for storing the elements inside the DEQUE data structure. Right. So now see the first representation. A, B, C, D and E. So this is an array representation. So if you see, all the elements are being stored inside this DEQUE data structure, isn't it? So meaning is the structure is full, we cannot able to store the elements. So in this case, what will be the condition? So f value is 0, isn't it? So r value is 4. F value is 0, right? And r is equal to 4. So in this case, is it possible for us to store the elements? No, it is not possible. So it will display as full, right? So how we will be writing the condition for this? So if f is equal to 0 and r is equal to, what is the value of n? So n value is 5, isn't it? So n value is 5. So you must have to write it as n minus 1. So if this condition is satisfied, we are printing the message as full, right? So the same condition we can use it for here also. If you are using the rear pointer for inserting the element, so at that case also, if the DEQUE data structure is full, we are going to print it as full, nothing else to do, isn't it? So you can use the same condition here also, if f equal to 0 and r equal to n minus 1. Okay, so first I think so you have understood. So now we will go for the second case. So what is the second case? If in this data structure, the element representation is like this. See, for example, there are only 3 elements that is being present. So the 0th index is also empty and 4th index also is empty. So now we are using front pointer. We are going to navigate the front pointer for inserting the elements. So that alone you just see. So front pointer, where the front pointer is present? So it is present over here. So how I will be inserting the element? First, I must have to move to this location if this is empty, isn't it? So by seeing I can tell it is empty. But while using the condition checking only, the system will tell that it is empty, isn't it? So we are going to write a condition for decrementing the front pointer here. What we are going to do? We are going to decrement, isn't it? So I must have to move one step before and I am going to insert the element. So for that, what is the condition? See, if f is equal to 1, can I write like this? Yes, you can write. So if f is equal to 1 and r is less than n minus 1. If f is equal to 1 and r is less than n minus 1. So why I am writing this r is less than n minus 1? Because there may be case that we will be incrementing the rear pointer. This should not happen. So for that I am checking this condition. I must not increment the rear pointer and enter the element. Instead, I must have to decrement the front pointer. I must have to insert the element. Right? So this also you should have to take it into consideration, friends. Right? So for that I am using this condition. Right? If the element is present in rear pointer, you will be having a different condition checking, right? So see, there will be a small difference that is being present between both, right? So if both the sides are empty, if front and rear are empty, I am using less than n minus 1. If rear is having an element, I am using n minus 1, r is equal to n minus 1. So that is the little bit of difference, right? So there is a slight difference between this front pointer also. If you just watch, f is equal to 1 and f is less than n minus 1. So what is the difference is, in this case of a diagram, we are going to check only for one move. If there is only one place for inserting the element in the front, right? So for that you should have to use f is equal to 1. Next, if there are many more elements to be inserted before the front pointer, so for that I cannot use this, I can use only this, that is f is less than n minus 1. So meaning is, before the front pointer there are still many more spaces for inserting the elements in the position, right? So that is the differences, you must have to have a clear idea, right friends? So if there is only one move, I am using f is equal to 1. If there is many more moves before the front pointer, I am using f is less than n minus 1. Okay friends, are you all clear? So now we will go for this discussion. So once again, you take this example B, C, D. So in front portion, I have only one element to be inserted. So I am using this condition if f is equal to 1. So is this condition satisfied? So f is equal to 1. So this condition is satisfied. And r is less than n minus 1. So see, r is less than n minus 1. So what is n? So n value is 4. So 4 minus 1, you will get the value as 3. So this condition is also satisfied. Suppose if both are satisfied, we are decrementing the front pointer by one move. So what will happen? We are decrementing the front pointer here, right? Decrement, and I am going to add the element. So let the element be x. So like this, I am going to add the element by decrementing the front pointer. So this is the condition for if and only if one element has to be inserted in my front location. Okay friends, are you all clear? So right. So next one, we will see this possibility. If the rear element is full, that is the rear index value is completely filled with that of the elements, and before front pointer we have only 2. That is more than one element is to be inserted. So for this, I cannot use this f equal to 1. So what will happen? It will stop if this condition is satisfied. So in order to avoid this, I am using this condition, meaning is more than one element has to be inserted in my front side. If it is there, it will move to this step. So see, if f is less than n minus 1, is this condition true? So what is n value? So n value is 5. So here also 5, sorry friends, right? So n value is 5. So 5 minus 1 is 4. So is this condition satisfied? What is f value? So f value is 2. So 2 is less than 4. So condition is true. So the system will understand that. So there are still many more elements has to be inserted. And r is equal to n minus 1. Right? So why we are using this condition? R is equal to n minus 1. So why we are using both this condition is we are giving importance for the front pointer. Right? So the compiler will understand that if there is this possibility occur, I must have to use my front pointer only to insert the element. Okay. So if r is equal to n minus 1, so what will happen? So here it is full. So the compiler will understand that this area has to be filled. So once again, I am decrementing the front pointer here. So f is equal to f minus 1, decrementing, and I am going to add any other element. So y. Right? So like this, I am going to insert. Friends, are you all clear? So these two conditions are very important. So if one element has to be inserted in the front, this is the condition. If more than 2 or 3 elements has to be inserted in my front position, this is the condition. So please make a note. So like this, they may ask in examination, that is an MCQ they will ask. So you should not have any confusion. You must have to answer it rightly. Right? So for that purpose only I have written and I have explained you. Right? So now we will go for the fourth condition. So what is this fourth condition? See here, in this diagram, front element is full. See, the front pointer is pointing to the 0th element and all the successive elements are full and fourth is empty. So how can I insert in this area? So I must have to give importance for the front pointer, isn't it? So I must have to move this front pointer to this location and then only I can insert, isn't it? So front has to be moved to crossing 1, 2, 3, all these index values, and then you should have to point here, isn't it? So f has to be 4. For this only I have written this point. Okay. So if f is less than 1, what is this condition? Means, so f is less than 1, meaning is f is equal to 0. So value is 0, isn't it? And r is less than n minus 1. So what is the meaning? There is one more element has to be inserted in the last index value. So for that we are making all these references, right? So this is also true. So what is r value? 3 less than 4. So this is also true, isn't it? So if this condition is true, I am going to reinitialize. What? I am going to initialize, that is reinitialize the value to 4, f is equal to 4, and I am going to insert the element. So for example, I will insert any other element, let it be yes. Friends, right? Are you all clear? So this is the way we are giving importance for the front pointer for inserting the elements inside the DEQUE. I think so now you will be having a clear knowledge of using or moving the front pointer here and there, right? So now we will see for the rear condition. Okay. So now we will see for the simple condition first. So take the first option. So in this area already I told it is full. So if this condition is satisfied, right, if this condition is satisfied, it is going to print as full. So the same condition will come. So next you will see for the second possibility. So take the same representation, see the front position. So the front position is empty and rear position is here. So if this happens, how we are going to move the rear pointer for inserting the elements? So where I should have to insert? I must have to give importance for the rear pointer, isn't it? So I will move this rear pointer for inserting the element. So what will be the condition? We can use the same condition, isn't it? See, if f is equal to n, same one, and r is less than n minus 1. Okay, so what is the condition? F is equal to 1. See, if there is only one element present, that is one element has to be inserted before the front pointer, and there is one more element has to be inserted in the rear pointer, we are not going to use the front pointer. Okay, we are using the rear pointer to increment and we are inserting. Okay, so this is a very important point, that is, this is a very important representation. So you should have to have a clear idea. For that purpose only I have represented each and every cases of diagrams. Okay friends, so now the conditions are more or less same only friends, right? So this is very important. See, the conditions are repeating. If it is this case, we are not making front pointer to decrement. We are incrementing the rear pointer instead and we are inserting the element. So what will happen? We are incrementing the rear pointer to one location and I am inserting it as x. That is the simple difference. Okay. So now you see the third case. You please see whether it is possible for you to answer. See, now where is the front pointer? Front pointer is pointing to this location. So I am giving importance for rear pointer here now. Okay, so I want to, where I should have to insert the element. So I must have to reinitialize this rear pointer to this area. Right, I must have to reinitialize this rear pointer to this area if rear is pointing to the last index value. Okay, for this I have written this condition. If f is less than n minus 1, so what is the meaning? If rear is reached the last index value, it is not the meaning that the Q is full, DEQUE is full. That is, we are checking that is there any chance for inserting element before the front. So for that only each and every time we are implementing the conditions for checking both the front and the rear value. Okay. So now check if f is less than n minus 1. So this condition is also true. F is less than n minus 1. So what is f value? F value is 2. So f minus 1 is 4. So this is true and this is also true. Okay, so r is pointing to fourth value, so true. So what we are doing, here, so 2 is less than 5 minus 1 and r is equal to 4. Okay friends. So if this condition is satisfied, we are reinitializing to r equal to 0. Okay, we are reinitializing r is equal to 0. So the pointer will move here and we are going to insert any other element, it will be y. Okay friends, so like this only you must have to check the condition. Okay, so now what is the fourth case? So if the elements are in this form, how we will be inserting the element? We are going to give preference for rear pointer. Okay, we are going to increment the rear pointer to one location and we are going to insert it. So for that, what is the condition? F should be full. Okay, all the elements before the front pointer or at the front pointer has to be full. So for that we have checked. So f is less than 1. So meaning is f is equal to 0. So meaning is f is equal to 0. So this is true, isn't it? F is equal to 0 and r is less than n minus 1. So r is less than n minus 1. So what is r value here? So r value is 3. So 3 is less than 4. So this condition is also true. So now we are incrementing the rear pointer to this location and we are inserting the element. Like this we are going to do the operations, friends. I think so now you have got a clear idea about how to use the front pointer and rear pointer for making just the insertion. So now we will see how to delete the operation by using the front and rear pointer, right? So in the next video we are going to discuss it, right? So friends, if you like this session, I request you to subscribe this channel, okay? And give your valuable comments also. Okay friends, bye.